Lesson 49, linear intercepts and transversals. A lot of times when we look at graphs, we can determine a lot of things just by looking at it. We can figure out the slope by looking. We can determine where the line crosses the y-axis or the y-intercept. But a lot of times you can look at a graph and the whole graph may not show where the point crosses the y-axis or the linear intercept, the point of interception. So we're going to use a few steps to solve for the equation of the line without knowing what the intercept is. So we're going to follow just a few steps. Step number 1 is to estimate the slope. We estimate the slope by choosing 2 points on the line. I'm going to choose the point here where it crosses at 4, -2. And I'm going to choose the point here where it crosses at 3, 1. From that, I can get my slope. From -2 up to +1, I moved 1, 2, 3 places. And to get from 4 over to 3, I moved 1 place. Okay, remember slope is always rise over run, or change in x over change in y. So our slope is 3, 1, and it's going to be negative because our line is going downhill from left to right. So our slope is -3 over 1, or just -3. Step 2 is to substitute the slope and an ordered pair into the equation of the line in order to find the linear intercept. We're going to do this by, we're going to shorten this step to say estimate coordinates and substitute to find the y-intercept. All right, so our equation of a line we know is y equals mx plus b. We're going to choose just one ordered pair. I'm going to choose 3, 1. So we're going to substitute those values in, as well as our slope, into the equation to solve for our b, or to solve for our y-intercept. All right, so y is 1. Our slope is -3, and our x is +3. And we're solving for b. If we were to solve this out, our y-intercept would be b equals 10. And if you look at your line, you can see that it goes uphill, and it's going up at quite, at this angle. Once it crosses, it would be right about at where y is equal to 10. So you can also look at the graph to see if your answer is reasonable. The third step is to simply rewrite the equation of the line. And our equation for our new line, using our new slope and our new b, would be y equals -3x plus 10. All right, the next thing we're going to talk about, and the emphasis of the lesson, is about transversals. We've talked about transversals and how to find different angles in transversals, and we're going to use that information now to solve for sides in a triangle, in different angles in a triangle. So this one says find sides A and B. In order to find our sides, we need to determine what this angle P is here. In order to find what P is, we need to look. P and Z are going to be equal because they're both on top of the transversal being intersected, both on top of the pair lines being intersected by that transversal. So they're equal angles. So if we can find Z, we can alternately find P. In order to find Z, we know that this entire angle here is 180 degrees. So if this part is 153, then we know that Z is going to be equal to 27. And if we know that Z is equal to 27, we can also determine that P is equal to 27 as well. Now that we know an angle of the triangle, and we also have one of the sides, we can use our trigonometric functions to solve for A and B. Right? In order to use our trig functions, what we're going to do is we're going to base it off of this 27-degree angle. Okay? 27 degrees, we'll start with side A. In relation to this 27-degree angle, A is adjacent to it, and we're also given the hypotenuse, which is 7. So the function that goes along with adjacent and hypotenuse is tangent. So we're finding the tangent of 27 degrees, and that's going to be the adjacent over the hypotenuse, which is a over 7. And to solve for a, we go ahead and cross multiply. And if we cross multiply, adjacent and hypotenuse is not tangent, we'll be finding the cosine. Cosine is adjacent and hypotenuse. So we do the same thing. We're just going to multiply 7 times the cosine of 27 to solve for side A, which means that side A is going to be 6.23 if we round it to 2 decimal places. All right, now we need to find side B. So in relation to my 27-degree angle, side B is opposite. Opposite and hypotenuse uses the sine function. Okay, so sine of 27, since we're basing it off of that 27-degree angle, is the opposite, which is B, over the hypotenuse, which is 7. So we do 7 times the sine of 27, which means that B is 3.15. And that gives us both sides A and B. Let's do another example. This one we're doing the same thing. We're finding sides M and N, and we're going to do it based off of this A angle. In order to find A, we need to know that A and B are the same. Okay, they're both on the top side of their parallel lines that have been intersected by this transversal, so their angle measurements are going to be equal. In order to find what B equals, we need to look at this 158-degree angle. The whole thing, 158 and B, is going to be 180 degrees. So in order to find what B is, we need to do 180 minus 158, which means that B is going to be equal to 22. Once we know that B is 22, A is also 22. Okay. Now we can base finding M and N off of that angle A. All right, so let's start with M. M is adjacent to this angle, and we know the hypotenuse, so we're going to use the cosine function. The cosine of that 22-degree angle is the adjacent, which is M, over the hypotenuse, which is 90. So in order to solve for M, we're going to do 90 times the cosine of 22, which is going to give us 83.7. Now in order to find N, N is the opposite of that angle, so we're going to use the sine function, opposite over hypotenuse. So the sine of 22 is the opposite, which is N, over the hypotenuse, which is 90. And in order to solve for N, we're going to multiply the sine of 22 times 90, and that will give us 33.3. In this last example, you're finding side N. Now it looks a little different because we don't have any angle measurements listed for you, but you will have to fill in those missing angles in order to solve for side N.